All right, we're going to define a couple of things here in section 13.4. In section 13.4, we start talking about the idea of the inverse sine, the inverse cosine, and the inverse tangent. Now, all three of these basically say I give you some number, whether it's a decimal or a radical expression or whatever, and I ask you, for example, the inverse sine of the square root of 2 over 2. All right, and the inverse sine of the square root of 2 over 2 basically says this: what angle did I take the sine of and get the square root of 2 over 2? Now, remember, you have your unit circle at your disposal, all right? And if you've drawn that unit circle, you should be able to use that to kind of look at those numbers, look at the places around the circle where the sine is the square root of 2 over 2, and that should be able to tell you that that's 45 degrees. Now, I'll get into a little bit later on how you get that, but basically if I give you something, basically I'm saying, look, I took the sine of something and I got this. What was the something I took the sine of? All right, so it's kind of working backwards from the ratio and saying, what angle did I take the sine of to get this? What angle did I take the cosine of to get this? And that kind of stuff, all right? So I know that's not a great definition, but basically understand that the inverse sine, cosine, and tangent are giving you a ratio and saying, what angle did I take the sine, cosine, or tangent of to get that particular ratio, all right? Now, when we do inverse sine, cosine, and tangents, all right, the inverse trigonometric functions, basically your calculator is very valuable for this. We'll be using our calculator a little bit later on during this lesson to evaluate some inverse trig functions, but your calculator has the ability to do this. Now, one of the things that you have to be careful of is when I take the inverse sine, okay, when I take the inverse sine of an angle theta, written as theta equals inverse sine of A, where theta is equal to A, and what they're saying is your calculator is basically going to give you an angle between negative 90 degrees and positive 90 degrees. Now I want you to think about this. Sine, remember, sine is the y value. Every single ordered pair here is cosine theta, sine theta. All right? And so the sine is always going to be positive up here, right? Because those are all ordered pairs that are up. And then the sine would always be negative down here. All right? So if I asked you for the inverse sine of a negative 0.7, inverse sine of negative 0.7, that says what angle did I take the sine of and get negative 0.7? Well, if that's going to be negative, it's got to be down here in the fourth quadrant. So essentially what I'm saying is when you take the inverse sine of something, you're going to get an angle that's either in the first quadrant or the fourth quadrant. All right? And again, the reason for that is because sine is positive in the first and negative in the second. Now I realize you can get a positive sign here and a negative sign here, but our calculator is only going to be able to give us one angle in basically in between that range of values. All right, and then much later on during this lesson we'll talk about how we translate that to another quadrant. All right, using our reference angles. Now cosine's a little different. Remember, cosines are the x values. So x values are positive over here. Yes, I understand that cosine values are positive down here as well, but that's really not going to help us too much. When I take the inverse cosine, and I'll just put COS for inverse cosine, that's going to give me an angle that's somewhere between the first and the second quadrant. All right, because again, cosine is positive to the right because it's the x values, and cosine is negative to the left because it's, again, the x values. All right, so basically if I evaluate an inverse cosine, it's going to give me an angle between 0 and 180. Finally, the inverse tangent. Okay, recall that tangent is basically, your tangent is your sine over cosine. All right? Well, sines are positive in the first quadrant and positive in the first quadrant. So if I'm talking about the first quadrant, sines are positives, those are positives. So this is always going to be positive. Tangents are always going to be positive in the first quadrant. And in the fourth quadrant, okay, my sines, because those are my y values, those are going to be negative, and my cosines are going to be positive because those are in the those are to the right. So again, if you take the inverse tangent of some number, again, some decimal, some ratio, some radical expression, it's going to give you an angle that's somewhere between 90 degrees and negative 90 degrees. Now again, you just have to understand that when you're evaluating an inverse sine, cosine, or tangent, what angle it's going to be giving you, and then we can interpret that with our reference angles here in just a little bit. Okay? All right, so top of the next page, let's go ahead and take a look at evaluating some inverse trig functions. Now the first one's a little tricky here because they're saying the inverse cosine is equal to 3. All right, now I want you to think about that. Remember, the cosine, okay, every ordered pair is cosine theta, sine theta. And so we're asking you, when will the x value be equal to 3? Well, if I just go straight to the right, the cosine value is 1. And anywhere I go on this circle, okay, it's always going to be getting smaller than that, right? Because the x value is saying I'm not going as far to the right. If I go left, well, those are negative, and definitely not positive 3 here. So what I'm saying is the cosine can never be more than 1, all right? And since the cosine can never be bigger than 1, there is no angle whose cosine is equal to 3. So therefore, the cosine, the inverse cosine of 3 is undefined. Now, if you try to do that in your calculator, it's going to kick you back like an error or something like that. And I'll show you how to put that in just a moment here. Okay? Speaking of which, that's where we're going to go next. So the first thing I want to do then is I want to open up my graphing calculator, and I want to make sure that I press my mode button, and I want to make sure that my mode button has got me set in degree mode. Okay? If I leave it in radian mode, then when I take inverse sines, cosines, and tangents, it's going to give me an answer that's in terms of pi, but the calculator doesn't have any way of separating the pi, so I'm just going to get a bunch of ugly decimals here. So doing something in degrees is going to allow us much more flexibility in terms of getting these solutions. Okay? All right, so when I take the inverse tangent, okay, the first thing I have to understand is that when I take inverse tangent, okay, when I take inverse tangent, that's going to give me an angle between negative pi over 2 and positive pi over 2, or essentially between negative 90 degrees and positive 90 degrees. So if I want to take the inverse tangent of the square root of 3 over 3, we don't get those from our unit circle. Unfortunately, we don't see tangent values. Now, I certainly could go back and say that, well, tangent is sine over cosine. So you could evaluate every single sine over cosine in your table and see which one evaluates the square root of 3 over 3. Not a great idea. So to get the inverse tangent, you'll notice you have a tangent button here. We don't want to use the tangent, we want to use the inverse tangent. So you have to press second tangent, and now we're just going to take the square root of 3 divided by 3. Now, some things you have to be careful of with parentheses here. We don't want to take the square root of 3 divided by 3 because 3 divided by 3 is 1. So make sure you put the square root of 3 in parentheses to say that that's going first, and then divide that by 3. And oh, by the way, we're taking the inverse tangent of the whole thing. So it's kind of important to recognize that this parenthesis goes with this one. That closes off the end of the radical. And then when we're done taking the inverse tangent, we need that parenthesis on the end. Okay? Now, you may get similar results, but you may get better results, you know, with or without those parentheses. My guess is that you need those all in there, but I haven't played around with it enough to know for sure. So anyway, we end up getting the inverse tangent of radical 3 over 3 is simply 30 degrees. All right, and so we're going to put in here that this is 30 degrees. And then all we have to do then is say, well, if I know that that's 30 degrees, let's go over to our unit circle, and let's take a look at 30 degrees. All right, now we know that 30 degrees, according to our unit circle, is pi over 6. It's right here in our graph. All right, so we just did the inverse tangent of radical 3 over 3, and we said that's 30 degrees. Well, that also converts to pi over 6, or certainly you can multiply by pi over 180 as well to convert that. But this is pi over 6. All right? So, again, as I told you before, there's a payoff. You guys have been working on this unit circle for how long now? All right? There is certainly a payoff to this, and so let's kind of take a look at where it pays off for us. We want to know where is the inverse sine equal to the square root of 3 over 2. Okay, inverse sine is square root of 3 over 2. So what I'm going to do is I'm going to go over to my unit circle, and again, we're looking for the inverse sine. Sine, remember, every ordered pair is cosine theta, sine theta. So we want to find an ordered pair whose y value is radical 3 over 2. Now, again, certainly you can type inverse sine of radical 3 over 2 in your graphing calculator, and it's going to kick you back an answer, but you're already going to have spent so much time on this unit circle, why not just utilize it for what it's for? So we want to find something with a y value of radical 3 over 2. Okay, this one has a y value of radical 3 over 2 because we're up square root of 3 over 2, and so does this one. All right, remember, it's the y value. So it's either 60 degrees or 120, and as you guys remember, hopefully you remember from the previous page, when we take inverse sines, we're taking inverse sines basically from 90 degrees down here to negative 90 degrees. So basically from 90 to 270. So anything on the right side is kind of what we're looking for, and so it has to be this one, which is 60 degrees. All right, so if I go back over here to my notes, I can tell you right now that this is 60 degrees or pi over 3 radians. All right, what about the inverse cosine is negative a half? Now again, cosines are x values, cosines are negative over here, right? Cosines are negative over here because those are all to the left, but when I take inverse cosine, it's going to give me values in the first quadrant and the second quadrant. All right, so whatever I'm looking for is somewhere here in the second quadrant. Now again, the cosine is the x value, so look at your picture and say, where is the cosine value negative a half? Again, what has an x value of negative a half? Looks like 120 degrees. Okay. All right, and 120 degrees happens to be 2 pi over 3 radians. Okay? All right, and then finally the last one is the inverse tangent of negative 1. Now there's a couple different ways to think about this. Realize that tangent is sine over cosine. All right, and so to get 1, basically we want the same thing on the top as on the bottom. All right, so we want to find an ordered pair that has the same numbers top and bottom, or the same sine and cosine. The only difference is I want one of them to be negative and one of them to be positive. When you take inverse tangent, it's going to give you something in the first quadrant or the fourth quadrant. All right, and for tangent to be negative, it's going to have to be down here. Okay, it's going to have to be in this region down here, because that's the only place that you're going to get one of each. Again, if you're up in this region up here, they're both going to be positives, right? It's going to be a positive over positive. So down here, this is to the right, so the cosine is positive, but over here, the sine is negative because it's down. So we want to find a point that's down here someplace that has the same x and y values, all right, just different signs. All right, so we go back over here to our graph, to our completed unit circle, and as you can see right here, 315 degrees has the same x and y value, and so if I do sine over cosine, it becomes negative radical 2 over 2 divided by radical 2 over 2, and you get the same thing. A much easier way to do that is to simply say, what's the inverse tangent of negative 1? And it tells me it's a negative 45 degree angle. Now again, a negative 45 degree angle is a clockwise rotation of 45 degrees, which is also the same as 315 degrees. All right, so either of those would be sufficient for that. All right, so let's go ahead and slide over to the next page. What happens if the numbers aren't so pretty? What happens if they're not numbers we can get from our chart? Well, this one wants us to solve the equation where the cosine is equal to 2/5. Now you have to think about this first. Cosine is equal to 2/5. Probably should pick a different color here. Cosine is equal to 2/5. Well, again, the cosine is a positive number. They're saying cosine is positive, and as you recall, every ordered pair is cosine theta, sine theta. So we have to ask ourselves, where are cosines positive? Well, that's any place to the right. So first quadrant and fourth quadrant. They ask us to find an angle between 270 and 360, but if I take the inverse cosine is going to give me an answer up here in the first or second quadrant. All right? So when I take the inverse cosine of 2/5, it's going to give me something here in the first quadrant, because that's the only place where cosines are positive when I evaluate inverse cosine. So if I take the inverse cosine of 2/5, you guys can plug that into your calculator. The inverse cosine of 2/5 ends up being 66.4 degrees. All right? So that says if I'm up here 66.4 degrees, that will have an x value of 2/5. Now, I don't really care what the y value is, and I could figure it out if I wanted to, but it's not like it really matters. Now I need to find an angle with the exact same x value that's down here in the fourth quadrant, because I need to be between 270 and 360. Well, something that's going to have the exact same x value is something that goes the same distance to the right, so basically reflect that point down here. All right? Now, if I'm thinking about that in terms of a reference angle, this right here is a 66 degree angle. Okay? So if I went backwards or clockwise from 360 degrees, 66.4 degrees, basically just do 360 minus 66.4, Okay, again, that angle has to be in this angle here, 66.4, is in the first quadrant, but I need an angle in quadrant 4. All right, so the angle with the same cosine value would then be 360 minus 66.4, which we come out to 293.6 degrees. All right, and again, it has to be between 270 and 360, and it is. All right, so again, the big thing for that is take the inverse cosine and realize that it's going to give me an angle in the first quadrant. That's not between 270 and 360. So I need to reflect that reference angle down here where it's going to have the same x value. It's going to have the same x value. All right, similar to what we did way back when we created our unit circle. So I'm hoping that conceptually you can use that unit circle to help you answer some of these inverse questions. All right, now for this one, find the measure of the angle shown. Now, again, when you take inverse sine, we know that the sine, for example, is the ratio of opposite over hypotenuse. Well, that's opposite over hypotenuse. In this case, the opposite side's the 5, the hypotenuse is 13. So if I want to know what that angle is, then I have to take the inverse sine of 5 over 13. And again, make sure your calculator's in degree mode. You should get 22.6 degrees for this. All right? So be careful when you use your calculator, and I don't know if this is going to work or not. I want to just play with it. The inverse sine of 5 over 13, and you just do it like that, it does come back to 22.6 degrees. So it looks like you don't need that in parenthesis there. It'll do it just fine without it. Okay? So that tells me this angle is a 22.6 degree angle. Obviously, that's an acute angle, so we don't have to worry about monkeying around with other angles for that. All right? Okay, so let's take a look at this last one. There's 2 checkpoint problems, and we'll finish up here. So solve the equation where the sine of theta is 0.7, and I want an angle between 90 and 270. So let's draw my unit circle first. 90 and 270 is over here someplace. All right? Now, I know when I take inverse sines are going to give me angles in the first quadrant and in the fourth quadrant. So I'm going to get angles down here. All right? Now, let me ask you this. Where are sines positive? Well, sines are positive. Remember, sines are positive to the top, anywhere that's up. So when I take the inverse sine, it's going to give me something that's actually up in this region here, all right, because it's a positive number. But I want to then reflect that angle so that it's over between 90 and 270, so we're going to have to do a little bit of work to this. The first thing we want to do is take the inverse sine of 0.7. Inverse sine of 0.7, and that comes out to a 44.4 degree angle. All right? So this is a 44.4 degree angle. Okay, and so I'm just going to kind of say, all right, it's right about here, 44.4 degrees. And that is not between 90 and 270. So I need an angle with the exact same y value. Remember, this is cosine theta, sine theta. Every ordered pair on the unit circle is cosine theta, sine theta. The y values are my sine values. So I need to find another angle that has the exact same y value as this 44.4 degree angle. So all I have to do is reflect this angle over here. So it has the same exact y value. All right, well, I can see then that that's 44.4 degrees short of 180, so I find the reference angle for 44.4, 180 minus 44.4, and that comes out to be a 135.6 degree angle. Okay, now, by the way, a great way to check your answer is to simply take the sine of 135.6, and you should get something close to 0.7. Obviously, we had to do some rounding here. All right, and then finally for this last one, in relation to this angle theta here, we have the opposite side, we have the adjacent side. So we have to go back to what we talked about in the very first lesson and say, all right, what ratio involves opposite and adjacent? Well, that's the tangent ratio. So I'm going to say the tangent of some angle theta is equal to opposite over adjacent. So then the inverse tangent of 5 over 8, when I plug that in my calculator, I come out with a 32 degree angle. All right, and so that's really the gist of lesson 13.4 on evaluating inverse trig functions.